All right, let's get started. Welcome back, guys. So I know that you're having trouble. Some of you are having trouble with the QR code for today. I don't know what's going on. Who's still having trouble? Okay. So you don't have permission on her. Yeah. You have to log into your, like, you have to go to Google, log into your email for your ASU thing. Yeah, definitely. Because I had that problem earlier in the semester. Yeah, something's fishy with this particular one. So just send the TAs an email that you reviewed, and we'll count that. Okay, so who enjoyed Sokwa's lesson last time? Pretty interesting, right? Kind of nice for me that I didn't have to cover it because I did just a little bit of malware analysis a long time ago, but not as much as Sokwa. So I was really grateful to him that he would be willing to come and do that lecture for us. So what's due today, everybody? The paper report and your paper presentation. If you're doing a presentation, please email that to me and the TAs. And what we will do is we'll come in and set up the computer here with your slides ready to go on the day that you're presenting. So if you're doing it in like Google Slides, then you probably need to save it as a PDF so that we can put it up here and not have to log in or something like that. Or PowerPoint will be fine too. Okay, what is due a week from today? Email assignment. How's that coming? Any problems? It's a pretty simple assignment once you understand what you got to do. I did have a question about the from field. So I didn't realize that in the 90s the standard for the from field was a little bit different than it is today. So all of the email headers that start with an X, that's kind of a way to say I'm doing a new header. I know about it, but not everybody might know about it. There's an X from description, or I don't remember the actual name of the header name, but that's where the person's name went. And the from field had the email address. So it's a little bit of a different format than now, because now if you were to go into a modern email and pull the from field, it would have their name, and then in angle brackets, it would have their email address. So what I'm getting at is I'm follow exactly what the assignment says, which is pull whatever is from what is in the from field and use that. Don't try to like make it look like the output, the sample output in the assignment. Okay. But just pull the from field and the date field. That's the other one, right? So just don't worry about trying to put two things together and everything like that. Okay. Any other questions about homework 3? Okay. Hopefully you all got the announcements about the project description. So, any questions about that? Yes.
So with the current hash being removed so that it's verified, we no longer have to do part where we compare what it has versus the current checksum, since the current checksum no longer exists.
Yes. Yeah, so basically the last block in the chain then is kind of unprotected until there's another block added onto it. And that checksum is calculated and yes.
But you do want us to compare checksum of the block with the child's hash.
With a hash stored in the child block. Yes. Any other questions about the project or assignments or what to expect for the next couple of weeks? Yeah.
For makeup labs.
Oh yes.
So if we have like for example, I have like a 0 out of 1 for like attendance. So I should just come in and make up that lab. Like you sign up on the Piazza.
So Adam said he sent out the lab grades. I don't know what it looked like, so it's hard for me to match up your question without seeing that.
It was one of the labs where like nothing turned in or anything, so the grades were taken by it.
So lab 2? So lab 2, you don't have to come in and do.
Okay.
You can do at home and just take screenshots and email them to the TAs.
Okay.
Because there was nothing, like lab 2 was just an attempt to get you to do lab 1 kind of, but in autopsy. So go ahead and try to install autopsy on your machine. Follow those the instructions on the 3 links, the step 1, step 2, steps 3. Take some screenshots, send it to the TA, say, hey, this is my lab 2. So lab 2, you don't need a schedule if you need to make that. I think I saw another hand over here. Yes.
So I already filled out that I need to come in lab 2.
What?
Yeah, so do I send an email saying I'm not going to be showing up, or is it fine?
Yeah, go ahead and send them an email so they know. Any other questions? Okay, so, the other thing that's coming up is Tuesday. We have Jamie Winterton coming from GSI. She's awesome, so be the awesome students I know you are for her. Okay, let's go ahead and get into the lecture then.
What are the makeup labs do?
The makeup labs have to be done in person. Oops, totally did not.
What about the one that you just said that? Yeah.
Oh, please just do it soon.
Okay.
Like, I think all the makeup labs are next week, so it needs to be sent in next week. Last topic, guys. Last topic. I have some mixed emotions about this because, yeah, we'll get into that later. Okay, so we're going to talk about cloud and web forensics. This is basically the topic that I did my dissertation on, is web forensics, doing forensics in web environments and that stuff like that. So to get started, let's kind of level set our understanding of what a cloud is. Maybe we want to throw out their definition though. What's a cloud? Yeah.
Has rain in it.
Not the kind of cloud we're talking about. Yeah.
Someone else's computer.
There is no cloud, just another person's computer, right? Everybody seen that bumper sticker? Love it. That's not a very good definition. It's just a joke, right? Yes.
A way to store your data, but not on your machine.
Okay. We're getting closer. Anyone else want to try to define cloud for me? Wow, only took the community like 6 years to get it right. Yeah.
Share computing model distributed across the internet.
Hey, that's pretty good. So this comes from, this is a paraphrasing of NIST SP. The SP stands for Special Publication, SP 800-145. And this is NIST's, which is the National Institute for Science and Technology. So this is their definition: a computing storage system that provides on-demand network access for multiple users and can allocate storage to users to keep up with changes in their needs. So this definition is very storage-centric. There's more to the cloud than just storage, as we'll talk about in just a minute. But this is NIST's definition of the cloud. Really, you can think of the cloud as a whole bunch of layers of abstraction over computer hardware, operating systems, and software. And what that does is it makes it so you don't have to worry about it. So these layers of abstraction across hardware means that if you have a server, well, as opposed to having your own server, you can have a server in the cloud that can grow, a server infrastructure that can grow and shrink according to your need. So this layer of abstraction of using someone else's computer is actually super powerful because it really leverages economies of scale, right? Owning your own server, there's a lot of overhead that's involved with that. So if you can combine the overhead of maintaining servers, then suddenly you have a lot cheaper server service. Okay, so here's brief history of cloud, some of the high points that the textbook points out to you. I'm not going to read all of this to you, but a couple of them are of note, such as 1968 is when DARPA program plan number 723 about resource sharing computer networks developed into ARPANET, which was the predecessor to the internet. So that's 1968. 1999 was a big one because Salesforce developed a CRM website, which was kind of a first of its kind service that was scalable and all that. And then Amazon created Amazon Mechanical Turk and in 2002, and then 2006, they launched Elastic Compute Cloud. And I remember when that came out and everybody was like, what is this? What is this? It kind of took a while for everybody to really kind of catch the vision of how awesome cloud computing could really be. And by 2009, everybody started publishing new services, right? And also, I guess, noteworthy this week is also in 2006. What happened? Let's see. I'm doing my math wrong. Never mind. I told you, arithmetic and my brain don't get along, so I'm just going to breeze right over that. Okay, cloud service levels. Here are the 3 cloud service levels. The first, at the very top or closest to the user, is software as a service. Got a couple icons up here, but can you think of other software as a service services that fall into this category? Yeah.
Google Slides.
Yes. Yes, that is different than Google Docs. It is an icon I have up there. Yeah.
Webmail?
Webmail, very good. We should, yeah, go. YouTube. No. I'm going to say no. What software are you using? YouTube. So it's a website. But so YouTube is a very scaled website, but I wouldn't call it software, right? You're just viewing content that's different than software, right? So here we've got an application that's delivered via the internet. So instead of Microsoft Word, you have a web version of that program that isn't installed locally. I got some complaints. Yes.
Oh, I was gonna say another example is like I Googled like PDF to docs like converter.
Yep.
I don't know if this is right, but I want to hear your take. Like social media sites, just like Facebook, Twitter, is that software as a service? If I like say I'm using Facebook Messenger, I'm using it to share content or publish content.
That's an interesting question. I don't know where the line is. Because if there's not really an analogous program that you would normally install on your computer, right? To install locally. So in order for something to be classified as software as a service, there has to be that instead of installing something here, I'm going to use it through the web. Yeah.
Does that mean that all the old Flash games on Newgrounds are software? So
Yeah, I would, yes. Oh, it's dicey, yeah.
Extension like LastPass is software as a service?
Yes, it is. Yeah, I would, so I'm not the, some confused looks. That's okay. Let's gonna move on about whether this is SaaS or not. The key thing here is that the target of software as a service is the end user of an application. Now contrast that with the next layer down, which is platform as a service. So what this is basically an operating system that's installed on a cloud server that users can install their software and tools. So the target of this is the application developer largely. Okay, there are going to be some exceptions, but Azure, it is no longer just platform as a service. But when it first came out, it was really just a way to launch your applications in the cloud and take advantage of the Azure platform. There are more components to it now, but I can see in some people's faces that I'm offending you by how I'm defining things, but that's okay. Application developer is the target here. And the bottom layer is infrastructure as a service. So this is where a customer will rent their hardware, they install their OS of their choice, highly configurable network options, tremendous scaling ability, and the target is really kind of more the system administrator in a sense. Yeah?
What would you consider like Travis CI?
That's more of software as a service, yeah. Yeah.
What about things such as like WCF? That'd be more platform as a service or software as a service, like service-oriented data models.
I'm not familiar with WCF.
So as kind of like a successor to RESTful web.
Okay. So I'm not going to answer that question because if you take a look at the textbook, it says now these 3 layers, these were like the initial 3 layers. And now NIST recognizes more like 63, 65, some odd, something as a service, right? So to split hairs, especially in a classroom like this, it's kind of a futile effort, right? Because if we're going to try to shove everything that is a service on the internet that uses the cloud, we're going to get really frustrated really quickly, right? But these are the foundational 3 layers of the cloud. And all right, any questions about these 3 layers? He still tell you like, you don't agree with me. You have any thoughts you want to share?
We want to go to the next slide.
So in my defense, some of the wording here, I did pull right from the textbook. So and I do have a PhD kind of in this area. So, you know, I'm just saying. Okay, let's talk about cloud deployment methods. So what do I mean by this? Well, first, there's the public cloud. There's different types of cloud that indicate how to access it and who can access it. The first is public. This is where the cloud services are available to anybody. And so this would be something like Amazon AWS, Amazon Web Services, right? Anybody can go in, make an account, give them money, and start using their services. Contrast this with something like a private cloud. This is where someone, like a company would set up their own internal cloud on servers that they own. So just because you want to use a cloud doesn't necessarily mean you have to use somebody else's computer. You could use your own computers and still take advantage of all the layers of abstraction that come with the cloud on your own internal infrastructure, right? In that case, if you install something like OpenStack or there's several other private cloud architectures that you could use, and give the users of that cloud a little bit more limited access. And this is typically an on-premises kind of an installation. Okay. This one I had never heard of until I read it in the textbook, and I was like, what? So community cloud, a way to bring people together for a specific purpose. That is right out of the textbook. I never would have written that sentence. So moving on, hybrid cloud. Hybrid cloud is where you have a public and a private cloud that talk to each other. So let's say that you really love, your company really loves Amazon Lambda, right? Which is one of their cloud services that will basically run a function. It's like a function as a service, right? Yeah, not one of the 3. All it does is run a single function and then return the result. but the data that you process or something like that, you want to have in your private cloud. So you have your private cloud talking to a public cloud using their service. That really wasn't a very good example, but hopefully you get the idea that you have two clouds talking to each other. That's a hybrid cloud. And any questions on deployment methods for clouds? Anybody ever set up a cloud? I can, so we could commiserate with each other, right? Yeah, oh man. I would estimate that at least a year and a half of my life was wasted on trying to get OpenStack to work to do my research as a PhD student. It can be really great, but setting it up and administering it is kind of a nightmare sometimes. Oh yeah, gives company more control over data sources. Cybercrimes using the cloud. Anybody want to think of some cybercrimes that you can commit using the cloud? Yeah.
Rent like a server to run. So in my information assurance class, we had to crack password hashes, and one person I think rented like a cloud server to run their program so they could do it much faster.
Nice. Yep. Definitely. So what kind of crime would that be? Remember we talked about 3 different categories of computer crime?
Computer.
Okay. Any other crimes you can think of? This is a test. Yes.
AWS bot.
AWS botnet. I think that actually is the first one. Yeah. Yeah. Bots. Yeah. Very good. What else? Yeah.
What if you stored your illegal stuff in
Yeah. And
pictures?
what type of crime would that be?
That would be, I'm trying to remember the name, but that would be like the drug dealer who stored a list of his clients on there.
Yeah. What's the name?
Computer,
Runs.
can't remember the name, but
Incidental. Yeah.
cloud incident.
Perfect. Yeah. What else? How would you use a cloud? Yeah.
You could attack the cloud itself.
Yeah.
Yeah.
And what kind of
to say?
what kind of crime? What category of crime would that be?
Cloud targeted.
Yes, very good. Okay, so this is just like a short list that I came up with some help from the textbook, but it wasn't really tough. Data breach. So if you use a cloud as a tool to perform a data breach, then it would be cloud assisted. You could also do cloud targeted, where we launch a cyber attack against the cloud. So this would be a good example of this would be is that considered a cloud though? Think of the Mirai botnet, right, where all those IoT devices that have the default password got hacked into and were made a botnet, and it took down DIN, the DNS provider. So we just talked about this on Tuesday. So yeah, it wasn't the botnet wasn't part of a cloud anyway. Policy violations in accessing the cloud. So yeah, that's self-explanatory. Or data breach being the victim. So if a company stores their data in the cloud and that data gets hacked into and leaked, then that would be a data breach where the cloud was targeted. We also have cloud incidental, as we talked about, such as fraud, storing documents for fraud, data breach, meaning the storage. Yeah. So yeah, yes.
Could you hold a cloud for ransom?
Yes. Yes, but that's an interesting idea, because the level at which you would have to launch your attack would have to be kind of below the hypervisor. You have to get to something that is controlling the hypervisor on each of the servers. But yeah, absolutely. Okay, these next slides I actually copied and pasted from my dissertation defense. So they look a little bit different, that's why. One of the things that I did as part of my research was I came up with this framework for doing forensics in web environments. And the reason for that is, do you remember the forensic process that we talked about where you first do some you acquire the evidence, you authenticate the evidence, you analyze it, and then, oh yeah, you have to do a report, right? Yeah. So there's not really a place in that process for getting web data, right? So that's why I came up with this framework. So let's kind of take a step back though. Let's compare a traditional program with a web app. So in a traditional program, you have a program residing on the hard drive, right? And in order to execute, it has to be loaded into memory, and then each of the instructions are executed by the CPU. There might be other like DLLs or things that have to be accessed, and any storage is going to be loaded to and from memory, right, as you work with it. This is a very high level structure of a program that runs everything. Well, in the web, it's similar but different, right? In that you have a web app that gets cached in your browsers, on your browser, right? The browser executes the code and then also interacts with other web apps on the internet. Well, here's where things start to get really, not only is there a division here between where the app lives and where it's being executed in totally different machines, but you also have data that resides in the cloud. It might be in a different cloud, it might be the same cloud as the web app. Could be totally different. So for example, I don't know if you've noticed this, but Dropbox and Office Online, Office 365, they have a collaboration, right, where you can open a file that's being stored in Dropbox, but actually edit it in Microsoft Office Online, right? So that's an instance of where the web app and the file are actually living in two different clouds. And what is here? Maybe some caches. Very different in terms of doing forensics on these two, right? Hopefully that's clear by how it actually gets executed. So, because of that architecture, we have some unique forensic challenges that come up. So first of all, complying with the rule of completeness. How are we going to get enough evidence that we could tell a complete story with that evidence? Associating a suspect with online personas. So one person can have lots of different online accounts, right? So if all you have is the account information, how do you actually tie that back to the person that was responsible for performing those actions, causing the personas to perform those actions? It's a big challenge. Gaining access to the evidence stored online. Hopefully that's pretty intuitive, but if you've got data stored lots of different places, even just getting to one of those might be really challenging, let alone multiple storage locations. Third, giving the evidence context, both thematic context, meaning like the content, what's in it, and also temporal context. So we're going to create a timeline of what happened during the incident that we're investigating. There's challenges in ordering things correctly. And finally, integrating the tools to perform advanced analyses. So this really speaks to the fact that doing just one part of an analysis on evidence might not be enough, right? You need to have this one that specializes in this area for analysis, maybe pulling out certain files, but this one does the actual machine learning to figure out what the topics are or whatever it might be. Integrating those together is just another challenge. Okay, so here's this framework that I created. I love that I'm lecturing on this in class. And it came from my dissertation. Sorry, I just had to silk up that moment for a second. Okay, there are 4 parts to this framework. The first is evidence discovery and acquisition. So just like how the traditional process, the first step is acquisition, it's kind of the first step here, but it's not necessarily always going to be the entry point. And it's not just acquisition, it's discovery and acquisition. So the objectives that you're trying to do here is connect the suspect and the persona, gain access to the evidence from the web services, And these two address these challenges here. This is one of the things I had to do to like make it clear to my committee. I'm not just, the things I did actually match up with the problems I said we have. So that, not so much for you as for my committee when I made these slides. That's what I'm saying. Okay, analysis space reduction. So if, let's say hypothetically that we were able to gather all of the evidence that was, all of the data that was created by a suspect, right? That would be a huge, that would be a ton of data, right? Just think about how much data you have created online. Anybody ever use Google Takeout? Anybody know what Google Takeout is? Oh, only one person. This is awesome. Okay, so in your spare time, if you have tons of data, I think it's just takeout.google.com, and you can have Google basically put into a bunch of zip files all the data that they have on you from all their services. So, I mean, I recently used Google Takeout to gather all my Google Plus stuff because it's so valuable to me. I know. But I was just curious what it was, so Google Takeout, give it to me. Try it sometime. Even just looking at the list of services that Google has that might have data on you, it's kind of eye-opening if you've never looked through it before. So, yeah. So imagine having access to all of the data that you, yes, you individually created online. That would be a ton of data, right? So if you wanted to just identify evidence that proved you committed a crime, that would be a ton of data to sift through, right? So trying to provide thematic context of what is actually important and relevant to what we're trying to investigate, right? That's what we're trying to accomplish in this step of the framework. The next step of the framework, the next component is timeline reconstruction. So we take everything that we gather from evidence discovery and acquisition. Maybe we reduce the analysis space first, but then we need to organize it into a timeline, which will give us temporal context. And then finally, got to use structured formats. So this is really kind of a more of an academic requirement than anything, but in order to take forensic analysis to the next level, you got to be able to have tools that talk to each other. And in order to talk to each other, you have to have your data in a format that is structured so that the two different programs can actually talk to each other. That's basically what's on. Questions so far? We're going to talk about each one of these a little bit more. But okay. All right. These next few slides, I'm going to kind of step through a little bit more quickly, just because I don't have to prove to you that I earned a PhD anymore, because I already have it. Robert. Yes. All right. For each of these, I'm going to talk about what the examiner's process is, and also some of the challenges and stuff. Okay. So when an examiner does this step of the process, something that they would do is, first of all, discovery. They need to find anything on the evidence that they already have that might link back to accounts that the suspect has. So it might be cookies, it might be like a password vault, any kind of credentials, and then derive the corresponding service that those go to. Then actually do the acquisition, which might be tricky, right? You need to be able to get data from certain services. Each one of those services might have different APIs or method of getting that data, but you've got to know that once you've identified and discovered which services are of interest to you. Some of the challenges here are the volume of data, boundaries of data are ambiguous, both geographically and as far as ownership, and the user might have tons of accounts, right? Who here has ever forgotten an account because they hadn't used it in a long time, and then they like saw an old email about that account, you're like, oh yeah, I forgot to read an account there, right? So tons of accounts, right? Even so, if you were a suspect, would it matter to us in an investigation to acquire data from accounts that you created so long ago, you don't even remember it? Probably not, right? So unless it's like nearing the end of statute of limitations. Yeah.
On the previous slide,
Yeah.
where when you're talking about discovery, is that physical discovery, like the initial physical discovery of a client computer or client device?
So the assumption here is that we already have evidence, right? So cell phone or a laptop or something like that, right? And we've done our initial analysis of that evidence. If we're going to then try to augment the evidence that we physically have control over with stuff from the cloud, from web services, then we've got to actually figure out which web services to get data from. That's what it speaks. Okay. And actually, you'll notice that the structure of this is not like linear, a bunch of boxes or anything. All four of the components of this framework touch each other, and that's on purpose because maybe you have maybe you've done some timeline reconstruction and then recognize that something it appeared there's something to suggest that the suspect was using another web service that you haven't gotten data for. So you need to come back to this component and so 1, 2, and 3 you can jump between fluidly as your investigation proceeds and as you see fit. So, okay. Did I answer your question?
Yes.
Okay. Okay. Analysis space reduction. What the examiner here would do is there's kind of two different kinds of reduction that you can perform. First of all, it's classification, which basically you're trying to put labels on what the artifact's subject or theme or whatever it might be. So this could even be something like a keyword search, or anything like that. It could be considered a label. And then you got to filter for relevant labels. The second thing is identification. So this is where you would determine what the evidence is, and really only helpful when the evidence is encrypted. So my paper Deebling, which I think is paper 6, so one that we're going to talk about in a week and a half or so, a week and a half. This is where that paper kind of falls in and fills this void, right? Where you have encrypted data, you might not be able to decrypt it, but you still might be able to figure out what that data is, even if you don't know what the data contains. Cool, right? I was so proud of that paper. Like, you give me encrypted data, I'll tell you what it is without actually decrypting it. Cool, right? Okay, sorry, enough of my ego talk. All right, so some of the challenges in this space are false positives, because you might label an artifact as relevant when it's not, which results in suboptimal reduction, meaning analysis space reduction, which is the component we're talking about. False negatives, which obscures relevant data from the examiner, which alters the outcome of the investigation. So false negatives are actually not acceptable, especially when it comes to exculpatory evidence, which suggests innocence, right? Do we even, I don't even remember using the terms inculpatory and exculpatory. Inculpatory means it suggests guilt, exculpatory means suggests innocence, right? So how could you possibly have evidence that suggests you are innocent of a crime? What do you think? Yeah?
Like a geotag that corresponds.
Yeah, absolutely. But then you have to prove that the geotag was created by the same person, not just the phone, right? But yes, along those lines, perfect. Any other ideas?
A video of you doing something at a certain time.
Yes, love it. Absolutely. So exculpatory evidence is very prone to false negatives, meaning it's easy to overlook, because sometimes even just the easy to overlook or even just identify, hard to identify, because sometimes it's the absence of evidence that is exculpatory. So, kind of tricky. Okay, timeline reconstruction. What this looks like from the examiner's perspective is they first collect and combine all the time available data. Now this might require some F1 tools methods, remove irrelevant data, extra metadata, establish relationships between entries, chronological ordering, correlations, blah, 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 blah. So again, what I'm looking for you to learn from this framework is some of the high level concepts, not all of the nitty gritty, like what are the two different types of analysis space reduction techniques that you can leverage when analyzing web environment forensics evidence. Yeah, I bored myself with that sentence. Okay, let's just keep pressing on. Timeline reconstruction, some of the challenges here are incorporation into existing tools. So let's say that you were able to get a bunch of data as part of a forensic analysis investigation. Even if you had awesome time value data that's associated with that, your tools might not be able to process that, right? So for example, let's contrast analyzing a Word document with a Google document, Google Docs document. The Word document actually has like the metadata as far as like time values are concerned are really just the MAC, the modified access created times that the file system stores, and a few values internally stored inside the Word document, right? That's about it for time values. Google Doc documents have tons of metadata, like when the last time the owner opened the file, when the last time some person that the document is shared with made a revision or a comment, like tons of time data. So if you were to just get a copy of the actual Google, so let's say hypothetically you were able to get all that metadata about a Google Doc, throw it into FTK. Do you think FTK would be able to process all of that time metadata that it comes with? No, not at all, right? Because it hasn't been built to process all that extra metadata. So that's what I'm talking about here, is that some of web services, they aren't constrained by the file systems that we use on a regular basis, right? They can capture and store any time or other metadata values that they want to associated with data. So, very valuable for a forensic investigation, but using it in the tools is kind of difficult. Okay, a large variety of types of formats of logs, IoT devices is just an example. Reconciling time data from different sources and time zones. A lot of times you'll get time data on evidence and you have no idea what time zone it's in, which is then kind of somewhat useless if you can't figure that out, because then you can't reconstruct a timeline because you don't know what the offset is. Okay, last one is structured formats, and then we'll move on to not Mike's dissertation defense slides, okay? Hopefully they won't be as boring. Okay, structured formats. The way this looks from the examiner's point of view is hopefully they never have to worry about them. This is something that is more for the tools, not human using those tools. So because it's trying to get tools to talk to each other. But some of the challenges with structured formats is we have these three requirements. Precise representation of original data. So what I mean by that is if you're going to create a new forensic storage format and then use that in a court, you've got to show that the storage format is not a misrepresentation of the original evidence, right? You have to be able to show that transformation from original to your storage format is precise. Does that make sense? Method of verifying data conforms to specification. This is all academic stuff. Okay, so in summary, give me a PhD. No, just kidding. Here's what we've got. So this framework directly addresses the unique forensic challenges that we talked about earlier. It also gives examiners a way to approach web-based evidence. So this one was big for me as far as like what I wanted to provide with my dissertation, because I had a conversation one time with a forensic examiner for the state of Arizona, and I've been doing work on Chromebooks and things like that. And I asked him what he did, what they do at that lab when they get a Chromebook. And he said, we don't even try. We don't even make an attempt at analyzing them. And I was like, yeah, that makes sense. The reason why is because they're built to be so secure and so encrypted that trying to get anything off of those devices, unless you have my technique, is really kind of pointless and just way too high of a cost in terms of time and effort for very low yielding results. So being able to give examiners even a starting place was one of the things I was really proud of with my dissertation and the research I did in grad school. So also provides examiners with previously unknown data, relevant context. And as I talked about earlier, it has a non-sequential structure because you just, with web forensics, you don't know what you're going to need to do next. And then finally, it fits within existing forensic processes. So the forensic process that we talked about several times in this course, this can fit in with that workflow without breaking something. So, any questions about any of this stuff? Yes. Yep. Yes, that is a question. Yeah, no, it's really difficult because especially with things like email, right, that changes frequently. Twitter timelines change frequently. All sorts of data that's stored on the web and in the cloud, it changes frequently. So even if you do get a really precise representation of that data, who's to say that it won't change immediately after you collect it? So how could you possibly go back and verify that it's the same if it's changed, right? So it's a real problem, but here's the thing. When you have a known issue like that, and can say, here's the best we could possibly do because of this situation. The circumstances around cloud is that it changes all the time. So did we collect it properly in that moment? That's what it really comes down to. And given the constraints of the acquisition, was it done properly? So that's really kind of the position you have to take when you're defending the integrity of the evidence. That's a good question. Any other questions? Don't worry, I will not be offended if none of you ever read my dissertation. Okay, yes?
How long was it?
You know that website that you go to a lot that has my picture on it? Go to that website, it's there. You can look at the page number for yourself. I don't remember the number.
173.
Huh?
173 pages.
For my dissertation or my thesis?
Your dissertation.
Seems low. Numbered pages or total pages?
I think total pages.
I don't think so. Yeah, I don't remember. I thought it was more than that. Whatever. Okay, let's talk about a few other considerations for doing forensics in the cloud. The first is there's some legal challenges with doing forensics in the cloud. First of all, is some service level agreements. So among other things, service level agreements are really important to forensics because they state who is authorized to access data and what the limitations are when conducting acquisitions for an investigation. So if you're going to go in and actually and try to do an investigation where it involves the cloud, this is one of the first things you got to check is what is the cloud service provider, or the CSP, going to allow me to do as an investigator, even if they're cooperative, even if they were the ones that asked us to come in, they're still bound by this because it's an agreement between them and their customer whose data you're trying to get access to, and a binding agreement. Also, jurisdiction issues. This is huge. And nobody has a good answer for it because just the nature of the internet makes jurisdiction kind of an impossible problem to solve. Because the perpetrator, the victim, the instrument of the crime could all be in different locations, each of which might have different laws applying to each three of those. So what I mean by that is, let's say you have the perpetrator in country A, the victim in country B, and the tools that they used were actually on servers in country C, right? So country C might have a no access policy for things, right? Or country C might have laws that protect the victim, but the victim actually isn't in their country. Or country B, where the victim is, might have strong laws against the perpetrator, but the perpetrator is in country A. Like all of that dance of laws and everything, it's crazy. And yeah, accessibility. Two things about accessibility. So a search warrant can only be used in criminal cases. It has to be requested by law enforcement with probable cause, and is used to seize the actual hardware. If you don't need hardware, a subpoena or a court order would be enough because then you just get information. So this is where you would use. This is what you would use in like a civil case. Okay, some more technical challenges. Cloud architectures vary a lot. No two providers are alike for good reason, right? And there's a reason why Amazon and Google structure their cloud services that they sell differently. They think that a slightly different take on things is more advantageous, and so they sell those as benefits to their system over another system. So if they're underneath the hood, it's all architected differently. You have servers talking to each other in different ways, different protocols. Data might be stored in completely different ways. This is a big challenge if you're going to investigate a cloud service provider. Data collection and authentication, like we talked about earlier, remote acquisitions are hard. Also, you've got virtual network switches in those clouds. So you might have duplicate IPs and IP spaces. So even if you got all the data from these cloud instances, if you, for example, need to analyze the network logs, you might have duplicate IPs and think that, oh, this one's talking to this one, but really they're on completely different subnets, so there's no way they could possibly talk to you. It's crazy. Also, another common feature of cloud service providers is that they encrypt all their data. So if you're going to get at that data to analyze it, you got to get the cooperation of the cloud service provider. But a lot of times, even they can't decrypt it for security and privacy reasons. So it's a challenge. Analysis of forensic data, also verifying the integrity, like we talked about just a minute ago. Reconstructing the timeline is even harder. So forensics in the cloud is really hard. That's the big takeaway. Man, did I don't know what happened with my slides. Okay. Oh, that's right. We were talking about legal challenges, and then technical challenges, page 1, and then I'm so sorry. Okay, anti-forensics. Myriad ways of criminals to undermine evidence collection analysis. So You can have things set up in the cloud to like destroy evidence under certain circumstances, right? Way more than just that can happen. Incident first responders. So let's say you go to a cloud service provider to do some kind of analysis on data, right? They're going to have people whose job it is to do similar tasks. And you might need them to help you, but they might not be very well trained or cooperative or have the right training or whatever it might be. Role management. Oh, okay. So you figuring out who the owner of the data is, who the user of the data in a cloud environment is even harder, and is something you got to take into consideration when you're examining. And finally, standards and training. This is huge for law enforcement. There was like this whole area of research where people were trying to figure out how to minimize the amount of training that law enforcement would need for technologies as they came out, because there was such a deficiency in skills for analyzing new forensic evidence that they simply weren't keeping up, and it was generating a backlog, and there's never enough funding for training and everything. So this is a never-ending struggle to keep up with current technologies and approaches. Okay, levels of investigation. So this, I just want to talk for a second about the different types of investigation. So if you're going to investigate this cloud service provider, what this means is you've got to get detailed knowledge of the cloud's topology, like we were just talking about, like how their servers are structured and how they talk to each other, and data storage methods, all of that. If you're going to investigate the customers, the data could be stored computers, mobile devices, in the browser cache, like locally. So if you can't get the actual cloud data, these are still places that you need to look, because they might have portions of the data that could still be valuable. All that. Okay. And finally, locally stored cloud data. This is a little bit different than what we were just talking about, because this is where like you have a client that syncs with the cloud, right? So Dropbox client or Google Drive client, something like that. But with selective sync, like you can have folders that never actually get downloaded to the machine, right? So, but there would be evidence of those in artifacts that are on the machine, that like a directory listing of the remote server. I just said that, so I'm not going to say it again. Okay. Here's a conclusion. Each of the layers of abstraction that make cloud computing so awesome for the rest of the world make a forensics examiner's job way more difficult. Basically, every victory for privacy is a new challenge for forensics, right? And that's kind of a hard thing about forensics, is that you want there to be better privacy, but it's going to make your job of solving a crime that much more difficult, and it's kind of difficult. Any questions about cloud and web forensics? Yeah.
You said that there was the first response incident team that would be from the company. You said that they assist you. Do they actually perform any of the recovery? And if so, how does that impact your chain of custody?
That's a good question, but I'm not sure what the answer is. Okay. So I think the idea, what the textbook was kind of getting at when it was talking about that, is that you're coming in as a forensic examiner to a company where there's an incident response team that you're working with. It's probably the company that had a breach or something that they need to do the forensic examination on to figure out what happened, who's responsible, was there a crime committed, all of that. So in that case, it might not initially be a criminal investigation, just an investigation into the data breach itself. And so I don't know how that affects the chain of custody exactly, but it is a consideration. I don't know that chain of custody really applies until the evidence is in the hands of law enforcement. Right? Because you haven't actually acquired or seized the data as part of the investigation. So that's another consideration, is that how do you trust the incident response team to give you data that's valid, that is still has its integrity in place? That answer your question, kind of? Any other questions about this stuff? I just want to